The Hebrew or Jewish calendar is a lunisolar calendar used today predominantly for Jewish religious observances. It determines the dates for Jewish holidays and the appropriate public reading of Torah portions, yahrzeits, and daily psalm readings, among many ceremonial uses. In Israel, it is used for religious purposes, provides a time frame for agriculture and is an official calendar for civil purposes, although the latter usage has been steadily declining in favor of the Gregorian calendar. The present Hebrew calendar is the product of evolution, including a Babylonian influence. Until the Tannaitic period, the calendar employed a new crescent moon, with an additional month normally added every 2 or 3 years to correct for the difference between 12 lunar months in the solar year. When to add it was based on observation of natural agriculture-related events. Through the Amoraic period and into the Geonic period, this system was gradually displaced by the mathematical rules used today. The principles and rules were fully codified by Maimonides in the Mishneh Torah in the 12th century. Maimonides' work also replaced counting years since the destruction of the temple with the modern creation era Anno Mundi. The Hebrew lunar year is about 11 days shorter than the solar cycle and uses the 19-year Metonic cycle to bring it into line with the solar cycle, with the addition of an intercalary month every 2 or 3 years, for a total of 7 times per 19 years. Even with this intercalation, the average Hebrew calendar year is longer by about 6 minutes and 25 plus 25 over 57 seconds than the current mean solar year, so that every 224 years, the Hebrew calendar will fall a day behind the current mean solar year. And about every 231 years it will fall a day behind the Gregorian calendar year. The era used since the Middle Ages is the Anno Mundi epoch. As with Anno Domini, the words or abbreviation for Anno Mundi for the era should properly precede the date rather than follow it, although this is no longer always followed. AM 5773 began at sunset on September 16, 2012 and ended on September 4, 2013. AM 5774 began at sunset on September 4, 2013 and will end on September 24, 2014. AM 5775 will begin at sunset on September 24, 2014 and end on September 13, 2015. Components, day and hours. The Jewish day is of no fixed length. The Jewish day is modeled on the reference to "There was evening and there was morning" in the creation account in the first chapter of Genesis. Based on the classic rabbinic interpretation of this text, a day in the rabbinic Hebrew calendar runs from sunset to the next sunset. One complicating factor is that there is no clear-cut sunrise or sunset time at the extreme latitudes during certain seasons. At higher latitudes in summer, when the sun does not sink below the horizon, a day is counted from midday to midday, and in the winter, when the sun does not rise above the horizon, from midnight to midnight. There is no clock in the Jewish scheme, so that a civil clock is used. Though the civil clock, including the one in use in Israel, incorporates local adoptions of various conventions such as time zones, standard times and daylight saving, these have no place in the Jewish scheme. The civil clock is used only as a reference point in expressions such as, Shabbat starts at. The steady progression of sunset around the world and seasonal changes results in gradual civil time changes from one day to the next based on observable astronomical phenomena and not on man-made laws and conventions. Instead of the International Dateline Convention, there are varying opinions as to where the date changes. One opinion uses the anti-meridian of Jerusalem. Other opinions exist as well. Every hour is divided into 1080 halakim or parts. A part is 3 seconds or 1/18 minute. The ultimate ancestor of the helk was a small Babylonian time period called a barleycorn, itself equal to 1/72 of a Babylonian time degree. Actually, the barleycorn Norshi was the name applied to the smallest units of all Babylonian measurements, whether of length, area, volume, weight, angle, or time. The weekdays start with Sunday and proceed to Saturday, Shabbat. Since some calculations use division, a remainder of 0 signifies Saturday. While calculations of days, months and years are based on fixed hours equal to 1/24 of a day, The beginning of each halakhic day is based on the local time of sunset. The end of the Shabbat and other Jewish holidays is based on nightfall, which occurs some amount of time, typically 42 to 72 minutes, after sunset. According to Maimonides, nightfall occurs when 3 medium-sized stars become visible after sunset. By the 17th century this had become 3 second-magnitude stars. The modern definition is when the center of the Sun is 7 a degree below the geometric horizon, somewhat later than civil twilight at 6 a degree. The beginning of the daytime portion of each day is determined both by dawn and sunrise. Most halakhic times are based on some combination of these 4 times and vary from day to day throughout the year and also vary significantly depending on location. The daytime hours are often divided into shamoth-zemanioth or halakhic hours by taking the time between sunrise and sunset or between dawn and nightfall and dividing it into 12 equal hours. The nighttime hours are similarly divided into 12 equal portions, albeit a different amount of time than the hours of the daytime. The earliest and latest times for Jewish services, the latest time to eat chametz on the day before Passover and many other rules are based on shamoth-zemanioth. For convenience, the modern day using shamoth-zemanioth is often discussed as if sunset were at 6 p.m., sunrise at 6 a.m. and each hour were equal to a fixed hour. For example, halakhic noon may be after 1 p.m. in some areas during daylight saving time. Within the Mishnah, however, the numbering of the hours starts with the first hour after the start of the day. Weeks, Shavua, crescent is a weekly cycle of 7 days, mirroring the 7-day period of the Book of Genesis in which the world is created. The names for the days of the week, like those in the creation account, are simply the day number within the week, with Shabbat being the 7th day. Each day of the week runs from sunset to the following sunset and is figured locally. Names of weekdays. The Hebrew calendar follows a 7-day weekly cycle, which runs concurrently but independently of the monthly and annual cycles. The names for the days of the week are simply the day number within the week. In Hebrew, these names may be abbreviated using the numerical value of the Hebrew letters, for example unregistered trademark cubed, Yom Rishon unregistered trademark KKY, meaning first day, corresponds to Sunday, Yom Shani unregistered trademark K unregistered trademark meaning second day, corresponds to Monday, Yom Shlishi unregistered trademark KA unregistered trademark K unregistered trademark meaning third day, corresponds to Tuesday, Yom Revi'i unregistered trademark K unregistered trademark meaning fourth day, corresponds to Wednesday, Yom Chamashi unregistered trademark K unregistered trademark equals fifth day, corresponds to Thursday. Yom Shishi unregistered trademark KK unregistered trademark meaning sixth day, corresponds to Friday, Yom Shabbat unregistered trademark K, or more usually Shabbat K equals Sabbath rest day, corresponds to Saturday. The names of the days of the week are modeled on the 7 days mentioned in the creation story. For example, Genesis 1:5. And there was evening and there was morning, one day. One day in Genesis 1:15 is translated in JPS as first day, and in some other context as day 1. In subsequent verses the Hebrew refers to the days using ordinal numbers, for example, second day, third day, and so forth, but with the sixth and seventh days the Hebrew includes the definite article. The Jewish Shabbat has a special role in the Jewish weekly cycle. There are many special rules which relate to the Shabbat, discussed more fully in the Talmudic tractate Shabbat. In Hebrew, the word Shabbat can also mean, Talmudic, week, so that in ritual liturgy a phrase like Yom Revi'i unregistered trademark Shabbat means the fourth day in the week. Days of week of holidays. The period from 1 Adar to 29 Heshvan contains all of the festivals specified in the Bible Purim, Pesach, Shavuot, Rosh Hashanah, Yom Kippur, Sukkot, and Shemini Atzeret. This period is fixed, during which no adjustments are made. There are additional rules in the Hebrew calendar to prevent certain holidays from falling on certain days of the week. These rules are implemented by adding an extra day to March Heshvan or by removing one day from Kislev. Accordingly, a common Hebrew calendar year can have a length of 353, 354 or 355 days, while a leap Hebrew calendar year can have a length of 383, 384 or 385 days. Months. The Hebrew calendar is a lunisolar calendar, meaning that months are based on lunar months, but years are based on solar years. The calendar year features 12 lunar months of 29 or 30 days, with an intercalary lunar month added periodically to synchronize the 12 lunar cycles with the longer solar year. The beginning of each Jewish lunar month is based on the appearance of the new moon. Although originally the new lunar crescent had to be observed and certified by witnesses, the moment of the new moon is now approximated arithmetically. The mean period of the lunar month is very close to 29.5 days. Accordingly, the basic Hebrew calendar year is one of 12 lunar months alternating between 29 and 30 days. In leap years an additional month, Adar I, is added after Shavat, while the regular Adar is referred to as Adar II. The insertion of the leap month mentioned above is based on the requirement that Passover the festival celebrating the Exodus from Egypt, which took place in the spring always occur in the Northern Hemisphere's spring season. Since the adoption of a fixed calendar, intercalations in the Hebrew calendar have been assigned to fixed points in a 19-year cycle. Prior to this, the intercalation was determined empirically. The year may be intercalated on three grounds: Aviv, i.e. the ripeness of barley, fruits of trees, and the equinox. On two of these grounds it should be intercalated, but not on one of them alone. Importance of lunar months. From very early times, the Mesopotamian lunisolar calendar was in wide use by the countries of the Western Asia region. The structure, which was also used by the Israelites, was based on lunar months with the intercalation of an additional month to bring the cycle closer to the solar cycle. Num 10:10 stresses the importance in Israelite religious observance of the new month. In your new moons, ye shall blow with the trumpets over your burnt offerings. Similarly in Num 28:11. The beginning of the month meant the appearance of a new moon. According to the Mishnah and Tosfta, in the Maccabean, Herodian, and Mishnaic periods, new months were determined by the sighting of a new crescent, with two eyewitnesses required to testify to the Sanhedrin to having seen the new lunar crescent at sunset. The practice in the time of Gamaliel II was for witnesses to select the appearance of the moon from a collection of drawings that depicted the crescent in a variety of orientations, only a few of which could be valid in any given month. These observations were compared against calculations. At first the beginning of each Jewish month was signaled to the communities of Israel and beyond by fires lit on mountain tops, but after the Samaritans began to light false fires, messengers were sent. The inability of the messengers to reach communities outside Israel before mid-month high holy days led outlying communities to celebrate scriptural festivals for 2 days rather than one, observing the second feast day of the Jewish diaspora because of uncertainty of whether the previous month ended after 29 or 30 days. In his work Mishneh Torah, Maimonides included a chapter Sanctification of the New Moon, in which he discusses the calendrical rules and their scriptural basis. He notes, by how much does the solar year exceed the lunar year? By approximately 11 days. Therefore, whenever this excess accumulates to about 30 days, or a little more or less, 1 month is added and the particular year is made to consist of 13 months, and this is the so-called embleismic year. For the year could not consist of 12 months plus so and so many days, since it is said, throughout the months of the year, which implies that we should count the year by months and not by days. Names of months. Biblical references to the pre-Jewish calendar include 10 months identified by number rather than by name. In parts of the Torah portion note it is implied that the months are 30 days long. There is also an indication that there were 12 months in the annual cycle. Many countries in the Western Asian region used the Mesopotamian calendar from very early times, though the names of months varied. Prior to the Babylonian exile, the names of only 4 months are referred to in the Tanakh: Aviv first month literally spring. Ziv second month literally light. Hithanim seventh month literally strong in plural, perhaps referring to strong rains. And Bul eighth month. All of these are believed to be Canaanite names. These names are only mentioned in connection with the building of the first temple. Ha-Yen Kan Yuvgard suggests that the use of what are rarely used Canaanite names indicates that the author is consciously utilizing an arch-hazing terminology, thus giving the impression of an ancient story. At some point during the Babylonian exile or diaspora, which started in 597 BCE, Babylonian Jews began to use Babylonian month names, which continue to be used today. The Syrian calendar used in the Levant region shares many of the names for months as the Hebrew calendar, such as Nisan, Iyar, Tammuz, Ab, Elul, Tishri, and Adar, indicating a common Babylonian origin. Hebrew names and Romanized transliteration may somewhat differ, as they do from March Shvan or Kislev. The Hebrew words shown here are those commonly indicated, for example, in newspapers. In a regular year, March Shvan has 29 days and Kislev has 30 days. However, because of the Rosh Hashanah postponement rules, Kislev may lose a day to have 29 days, and the year is called a short year, or March Shvan may acquire an additional day to have 30 days, and the year is called a full year. The calendar rules have been designed to ensure that Rosh Hashanah does not fall on a Sunday, Wednesday or Friday. This is to ensure that Yom Kippur does not directly precede or follow Shabbat, which would create practical difficulties, and that Hoshana Rabbah is not on a Shabbat, in which case certain ceremonies would be lost for a year. Leap months. The solar year is about 11 days longer than 12 lunar months. The Bible does not directly mention the addition of embolismic, or intercalary months. However, without the insertion of embolismic months, Jewish festivals would gradually shift outside of the seasons required by the Torah. This has been ruled as implying a requirement for the insertion of embolismic months to reconcile the lunar cycles to the seasons, which are integral to solar yearly cycles. When the observational form of the calendar was in use, whether or not an embolismic month was announced after the last month depended on Aviv, i.e. the ripeness of barley, fruits of trees, and the equinox. On two of these grounds it should be intercalated, but not on one of them alone. It may be noted that in the Bible the name of the first month, Aviv, literally means spring. Thus, if Adar was over and spring had not yet arrived, an additional month was observed. Traditionally, for the Babylonian and Hebrew lunisolar calendars, the years 3, 6, 8, 11, 14, 17 and 19 are the long years of the Metonic cycle. This cycle, which can be used to predict eclipses, forms the basis of the Greek and Hebrew calendars, and is used for the computation of the date of Easter each year. During leap years Adar I is added before the regular Adar. Adar I is actually considered to be the extra month, and has 30 days. Adar II is the real Adar, and has the usual 29 days. For this reason, holidays such as Purim are observed in Adar II, not Adar I years. The Hebrew calendar year conventionally begins on Rosh Hashanah. However, other dates serve as the beginning of the year for different religious purposes. There are three qualities that distinguish one year from another, whether it is a leap year or a common year, on which of 4 permissible days of the week the year begins, and whether it is a deficient, regular, or complete year. Mathematically, there are 24 possible combinations, but only 14 of them are valid. Each of these patterns is called a qvayor, and is encoded as a series of 3 Hebrew letters. In Hebrew there are 2 common ways of writing the year number, with the thousands, called aka, and without the thousands, called ak gigahertz y. Anno Mundi. In 1178 CE, Maimonides wrote in the Mishneh Torah, Sanctification of the Moon, that he had chosen the epoch from which calculations of all dates should be as the 3rd day of Nisan in this present year, which is the year 4938 of the creation of the world. He included all the rules for the calculated calendar and their scriptural basis, including the modern epochal year in his work, and beginning formal usage of the Anno Mundi era. From the 11th century, Anno Mundi dating became dominant throughout most of the world's Jewish communities today. The rules detailed in Maimonides' calendrical code are those generally used by Jewish communities throughout the world. Since the codification by Maimonides in 1178 CE, the Jewish calendar has used the Anno Mundi epoch, sometimes referred to as the A-Euro-OE Hebrew era Euro, to distinguish it from other systems based on some computation of creation, such as the Byzantine calendar. There is also reference in the Talmud to years since the creation based on the calculation in the Seder Olam Rabbah of Rabbi Jose ben Halafta in about 160 CE. By his calculation, based on the Masoretic text, Adam was created in 3760 BCE, later confirmed by the Muslim chronologist al-Biruni as 3448 years before the Seleucid era. An example is the c. 8th century Baraita of Samuel. According to rabbinic reckoning, the beginning of year 1 is not creation, but about 1 year before creation, with the new moon of its first month to be called Molad Chohu. The Jewish calendar's epoch, 1 Tishrei Am1, is equivalent to Monday, October 7, 3761 BC in the proleptic Julian calendar, the equivalent tabular date, and is about 1 year before the traditional Jewish date of creation on 25 Elul Am1, based upon the Seder Olam Rabbah. Thus, adding 3760 before Rosh Hashanah or 3761 after to a Julian year number starting from 1 CE will yield the Hebrew year. For earlier years there may be a discrepancy. The Seder Olam Rabbah also recognized the importance of the Jubilee and sabbatical cycles as a long-term calendrical system, and attempted at various places to fit the sabbatical and Jubilee years into its chronological scheme. Previous systems, before the adoption of the current AM year numbering system, other systems were in use. In early times, the years were counted from some significant historic event. During the period of the monarchy, it was the widespread practice in Western Asia to use era year numbers according to the accession year of the monarch of the country involved. This practice was also followed by the United Kingdom of Israel, Kingdom of Judah, Kingdom of Israel, Persia and others. Besides, the author of Kings coordinated dates in the two kingdoms by giving the accession year of a monarch in terms of the year of the monarch of the other kingdom, though some commentators note that these dates do not always synchronize. Other era dating systems have been used at other times. For example, Jewish communities in the Babylonian diaspora counted the years from the first deportation from Israel, that of Jehoiachin in 597 BCE. The era year was then called Year of the Captivity of Jehoiachin. During the Hellenistic Maccabean period, Seleucid era counting was used, at least in the Greek-influenced area of Israel. The books of the Maccabees used Seleucid era dating exclusively. Josephus writing in the Roman period also used Seleucid era dating exclusively. During the Armudic era, from the 1st to the 10th century, the center of world Judaism was in the Middle East, primarily in the Armudic academies of Iraq and Palestine. Jews in these regions used Seleucid era dating. The Avodah Zarah states. Rav Harbi. Jacob then put this question: how do we know that our era of documents is connected with the kingdom of Greece at all? Why not say that it is reckoned from the exodus from Egypt, omitting the first 1,000 years and giving the years of the next 1,000? In that case, the document is really post-dated. Said Rav Naaman, in the diaspora the Greek era alone is used. He, the questioner, thought that Rav Naaman wanted to dispose of him anyhow, but when he went and studied it thoroughly he found that it is indeed taught, in a baraita in the diaspora the Greek era alone is used. The use of the era of documents continued till the 16th century in the East, and was employed even in the 19th century among the Jews of Yemen. Occasionally in Armudic writings, reference was made to other starting points for eras, such as destruction era dating, being the number of years since the 70 CE destruction of the Second Temple. In the 8th and 9th centuries, as the center of Jewish life moved from Babylonia to Europe, counting using the Seleucid era became meaningless. There is indication that Jews of the Rhineland in the early Middle Ages used the years after the destruction of the Temple. New Year. Exodus 12:2 and Deut 16:1 Set Aviv as the first of months, this month shall be unto you the beginning of months. It shall be the first month of the year to you. Nisan 1 is referred to as the ecclesiastical New Year. In ancient Israel, the start of the ecclesiastical New Year for the counting of months and festivals was determined by reference to Passover. Passover is on 15 Nisan, which corresponds to the full moon of Nisan. As Passover is a spring festival, it should fall on a full moon day around, and normally just after, the vernal equinox. If the 12th full moon after the previous Passover is too early compared to the equinox, a leap month is inserted near the end of the previous year before the new year is set to begin. According to normative Judaism, the verses in Exodus 12:1-2 require that the months be determined by a proper court with the necessary authority to sanctify the months. Hence the court, not the astronomy, has the final decision. According to some Christian and Keralite sources, the tradition in ancient Israel was that 1 Nisan would not start until the barley is ripe, being the test for the onset of spring. If the barley was not ripe, an intercalary month would be added before Nisan. The day most commonly referred to as the New Year is 1 Tishrei, which actually begins in the 7th month of the ecclesiastical year. On that day the formal New Year for the counting of years, Rosh Hashanah, is observed. This is the civil New Year, and the date on which the year number advances. Certain agricultural practices are also marked from this date. In the 1st century, Josephus stated that while Moses appointed Nisan as the first month for the festivals, the commencement of the year for everything relating to divine worship, but for selling and buying and other ordinary affairs he preserved the ancient order, i.e. the year beginning with Tishrei. Edwin Thiel has concluded that the ancient northern kingdom of Israel counted years using the ecclesiastical new year starting on 1 Aviv, while the southern kingdom of Judah counted years using the civil new year starting on 1 Tishrei. The practice of the kingdom of Israel was also that of Babylon, as well as other countries of the region. The practice of Judah is still followed. In fact, the Jewish calendar has a multiplicity of new years for different purposes. The use of these dates has been in use for a long time. The use of multiple starting dates for a year is comparable to different starting dates for civil calendar years, tax or fiscal years, academic years, religious cycles, etc. By the time of the redaction of the Mishnah, Rosh Hashanah 1:1, jurists had identified 4 New Year dates. The 1st of Nisan is the New Year for kings and feasts. The 1st of Elul is the New Year for the tithe of cattle. The 1st of Tishri is the New Year for years, of the years of release and Jubilee years, for the planting and for vegetables. And the 1st of Shavat is the New Year for trees, so the school of Shammai and the school of Hillel say, on the 15th thereof. The month of Elul is the New Year for counting animal tithes. Tu B'Shvat marks the New Year for trees. The table below shows the dates of the Jewish New Year. Leap years of 13 months. Leap years, the Jewish calendar is based on the Metonic cycle of 19 years, of which 12 are common years of 12 months and 7 are leap years of 13 months. To determine whether a Jewish year is a leap year, one must find its position in the 19-year Metonic cycle. This position is calculated by dividing the Jewish year number by 19 and finding the remainder. For example, the present Jewish year 5774 divided by 19 results in a remainder of 17, indicating that it is year 17 of the Metonic cycle. Since there is no year 0, a remainder of 0 indicates that the year is year 19 of the cycle. Years 3, 6, 8, 11, 14, 17, and 19 the Metonic cycle are leap years. To assist in remembering the sequence, some people use the mnemonic Hebrew word Gukadzati, where the Hebrew letters Gimel Vav Het Aleph Dalet Zayin Tet are used as Hebrew numerals equivalent to 3, 6, 8, 1, 4, 7, 9. The Qva'il records whether the year is leap or common, currency for pshuta, meaning simple and indicating a common year, and indicating a leap year. Another memory aid notes that intervals of the major scale follow the same pattern as do Jewish leap years, with do corresponding to year 19, a whole step in the scale corresponds to 2 common years between consecutive leap years, and a half step to 1 common year between 2 leap years. This connection with the major scale is more remarkable in the context of 19 equal temperament. To determine whether year n of the calendar is a leap year, find the remainder on dividing 7 AN, A plus A1, by 19. If the remainder is 6 or less it is a leap year. If it is 7 or more it is not. For example, the remainder on dividing, 7AA, A5774, A plus A1, by 19 is 6, so the year 5774 is a leap year. The remainder on dividing, 7AA, A5775, A plus A1, by 19 is 13, so the year 5775 is not a leap year. Rosh Hashanah postponement. To calculate the day on which Rosh Hashanah falls, it is necessary to first calculate the molad of Tishrei, and then determine whether the start of the year must be postponed. The molad can be calculated by multiplying the mean length of a lunar month by the elapsed time since another molad whose weekday is known. The molad Choi began 2 days, 5 hours, and 204 parts after the beginning of the week. The rules are complicated by the fact that the months subject to adjustment, March, Shvan and Kislev, are the 8th and 9th months of the ecclesiastical year while Tishrei is the 7th month. This means that adjustments must be made in 1 year in anticipation of the day of the week on which Rosh Hashanah will fall in the next year, which may itself be affected by the day on which it will fall in the 3rd year, and so on. The process is further complicated by the need to insert leap months in accordance with their own cycle. Nevertheless, only 4 possible adjustments are needed. These are called the Rosh Hashanah postponement rules, or DNIRIOT. If the molad occurs at all later than 18 hours, Rosh Hashanah is postponed a day. This is called DNIRIA molad zaken, meaning an old conjunction. If the molad occurs on a Sunday, Wednesday, or Friday, Rosh Hashanah is postponed a day. If DNIRIA molad zaken places Rosh Hashanah on one of these days, it is postponed a second day. This is called DNIRIA lo adu, an acronym meaning not 1, 4, or 6. The first of these is thought to be a relic of when the calendar was established empirically. The second is applied for religious reasons. Another 2 rules are applied much less frequently and exist to prevent illegal year lengths. Their names are Hebrew acronyms for the way they are calculated. If the molad in a common year falls on a Tuesday after 9 hours and 204 parts, Rosh Hashanah is postponed to Thursday. This is DNIRIA Radi, an acronym meaning 3, 9, 204. If the molad following a leap year falls on a Monday after 15 hours and 589 parts, Rosh Hashanah is postponed to Tuesday. This is DNIRIA Bitut Ka Poti, an acronym for 2, 15, 589. At the innovation of the rabbis, the mathematical calendar has been arranged to ensure that Yom Kippur does not fall on a Friday or Sunday, and Hoshana Rabbah does not fall on Shabbat. These rules have been instituted because Shabbat restrictions also apply to Yom Kippur, so that if Yom Kippur were to fall on Friday, it would not be possible to make necessary preparations for Shabbat. Similarly, if Yom Kippur fell on a Sunday, it would not be possible to make preparations for Yom Kippur because the preceding day is Shabbat. Additionally, the laws of Shabbat override those of Hoshana Rabbah, so that if Hoshana Rabbah were to fall on Shabbat, certain rituals that are a part of the Hoshana Rabbah service could not be performed. To prevent Yom Kippur from falling on a Friday or Sunday, Rosh Hashanah cannot be a Wednesday or Friday. Likewise, to prevent Hoshana Rabbah from falling on a Saturday, Rosh Hashanah cannot be a Sunday. This leaves only 4 days on which Rosh Hashanah can fall: Monday, Tuesday, Thursday, and Saturday, which are referred as the 4 gates. Each day is associated with a number, and these numbers are associated with Hebrew letters. Therefore the Qumran uses the letters, and to denote the starting day of the year. Deficient, regular, and complete years, the postponement of the year is compensated for by adding a day to the 2nd month or removing one from the 3rd month. A Jewish common year can only have 353, 354, or 355 days. A leap year is always 30 days longer, and so can have 383, 384, or 385 days. A Chazorah year is 353 or 383 days long. Both March, Shvan and Kislev have 29 days. The Hebrew letter, Het is used in the Qumran. A Kesatra year is 354 or 384 days long. March Shvan has 29 days while Kislev has 30 days. The Hebrew letter Kaf is used in the Qumran. A Shlema year is 355 or 385 days long. Both March Shvan and Kislev have 30 days. The Hebrew letter copyright Shin is used in the Qumran. Whether a year is deficient, regular, or complete is determined by the time between two adjacent Rosh Hashanah observances and the leap year. While the Qumran is sufficient to describe a year, a variant specifies the day of the week for the first day of Pesach in lieu of the year length. A metonic cycle equates to 235 lunar months in each 19-year cycle. This gives an average of 6939 days, 16 hours, and 595 parts for each cycle. But due to the Rosh Hashanah postponement rules, a cycle of 19 Jewish years can be either 6939, 6940, 6941, or 6942 days in duration. Since none of these values is evenly divisible by 7, the Jewish calendar repeats exactly only following 36,288 metonic cycles, or 689,472 Jewish years. There is a near repetition every 247 years, except for an excess of 50 minutes. Holidays, history. Mishnaic period. The Tanakh contains several commandments related to the keeping of the calendar and the lunar cycle, and records changes that have taken place to the Hebrew calendar. It has been noted that the procedures described in the Mishnah and Tosfot are all plausible procedures for regulating an empirical lunar calendar. Fire signals, for example, or smoke signals, are known from the pre-exilic Lachish ostraka. Furthermore, the Mishnah contains laws that reflect the uncertainties of an empirical calendar. Mishnah Sanhedrin, for example, holds that when one witness holds that an event took place on a certain day of the month, and another that the same event took place on the following day, their testimony can be held to agree, since the length of the preceding month was uncertain. Another Mishnah takes it for granted that it cannot be known in advance whether a year's lease is for 12 or 13 months. Hence it is a reasonable conclusion that the Mishnaic calendar was actually used in the Mishnaic period. The accuracy of the Mishnah's claim that the Mishnaic calendar was also used in the late Second Temple period is less certain. One scholar has noted that there are no laws from Second Temple period sources that indicate any doubts about the length of a month or of a year. This led him to propose that the priests must have had some form of computed calendar or calendrical rules that allowed them to know in advance whether a month would have 30 or 29 days, and whether a year would have 12 or 13 months. Modern calendar. Between 70 and 1178 CE, the observation-based calendar was gradually replaced by a mathematically calculated one. Except for the epoch year number, the calendar rules reached their current form by the beginning of the 9th century, as described by the Persian Muslim astronomer al-Khwarizmi in 823. One notable difference between the calendar of that era and the modern form was the date of the epoch, which at the time was 1 year later than the epoch of the modern calendar. Most of the present rules of the calendar were in place by 823, according to a treatise by al-Khwarizmi. Al-Khwarizmi's study of the Jewish calendar, Riza la Theistic Rajati 3/4 Ra Kh al-Yahudi extraction of the Jewish era describes the 19-year intercalation cycle, the rules for determining on what day of the week the first day of the month Tishri shall fall, the interval between the Jewish era and the Seleucid era, and the rules for determining the mean longitude of the sun and the moon using the Jewish calendar. In 921, Aaron ben Meir proposed changes to the calendar. Though the proposals were rejected, they indicate that all of the rules of the modern calendar were in place before that date. In 1000, the Muslim chronologist al-Biruni described all of the modern rules of the Hebrew calendar, except that he specified 3 different epochs used by various Jewish communities being 1, 2, or 3 years later than the modern epoch. There is a tradition, first mentioned by Hygiene, that Hillel b. Yehuda in the year 670 of the Seleucid era was responsible for the new calculated calendar with a fixed intercalation cycle. Later writers, such as Maimonides, explained Hygiene's words to mean that the entire computed calendar was due to Hillel b. Yehuda in response to persecution of Jews. Maimonides, in the 12th century, stated that the Mishneh calendar was used until the days of Abai and Rava, who flourished c. 320 350 CE, and that the change came when the land of Israel was destroyed, and no permanent court was left. Taken together, these two traditions suggest that Hillel b. Yehuda instituted the computed Hebrew calendar because of persecution. Graetz linked the introduction of the computed calendar to a sharp repression following a failed Jewish insurrection that occurred during the rule of the Christian emperor Constantius and Gallus. A later writer, S. Lieberman, argued instead that the introduction of the fixed calendar was due to measures taken by Christian Roman authorities to prevent the Jewish patriarch from sending calendrical messengers. Both the tradition that Hillel b. Yehuda instituted the complete computed calendar, and the theory that the computed calendar was introduced due to repression or persecution, have been questioned. Furthermore, two Jewish dates during post-Talmudic times are impossible under the rules of the modern calendar, indicating that its arithmetic rules were developed in Babylonia during the times of the Geonim. The Babylonian rules required the delay of the first day of Tishrei when the new moon occurred afternoon. The Talmuds do, however, indicate at least the beginnings of a transition from a purely empirical to a computed calendar. According to a statement attributed to Yos, an Amorah who lived during the second half of the 3rd century, the Feast of Purim, 14 Adar, could not fall on a Sabbath nor a Monday, lest 10 Tishrei fall on a Friday or a Sunday. This indicates that, by the time of the redaction of the Jerusalem Talmud, there were a fixed number of days in all months from Adar to Elul, also implying that the extra month was already a second Adar added before the regular Adar. In another passage, a sage is reported to have counseled those who make the computations not to set the first day of Tishrei or the day of the willow on the Sabbath. This indicates that there was a group who made computations, and were in a position to control, to some extent, the day of the week on which Rosh Hashanah would fall. Usage in contemporary Israel. Early Zionist pioneers were impressed by the fact that the calendar preserved by Jews over many centuries in far-flung diasporas, as a matter of religious ritual, was geared to the climate of their original country. The Jewish New Year marks the transition from the dry season to the rainy one, and major Jewish holidays such as Sukkot, Passover, and Shavuot correspond to major points of the country's agricultural year such as planting and harvest. Accordingly, in the early 20th century the Hebrew calendar was reinterpreted as an agricultural rather than religious calendar. The kibbutz movement was especially inventive in creating new rituals fitting this interpretation. After the creation of the State of Israel, the Hebrew calendar became one of the official calendars of Israel, along with the Gregorian calendar. Holidays and commemorations not derived from previous Jewish tradition were to be fixed according to the Hebrew calendar date. For example, the Israeli Independence Day falls on 5 Iyar, Jerusalem Reunification Day on 28 Iyar, and the Holocaust Commemoration Day on 27 Nisan. Nevertheless, since the 1950s usage of the Hebrew calendar has steadily declined, in favor of the Gregorian calendar. At present, Israelis except for a minority of the religiously observant conduct their private and public life according to the Gregorian calendar, although the Hebrew calendar is still widely acknowledged, appearing in public venues such as banks and on the mastheads of newspapers. The Jewish New Year is a 2-day public holiday in Israel. However, since the 1980s an increasing number of secular Israelis celebrate the Gregorian New Year on the night between December 31st and January 1st. Prominent rabbis have on several occasions sharply denounced this practice, but with no noticeable effect on the secularist celebrants. The disparity between the two calendars is especially noticeable with regard to commemoration of the assassinated Prime Minister Yitzhak Rabin. The official day of commemoration, instituted by a special Knesset law, is marked according to the Hebrew calendar on 12 March Shvan. However, left-leaning Israelis, who revere Rabin as a martyr for the cause of peace and who are predominantly secular, hold their commemoration on November 4. In some years the two competing Rabin memorial days are separated by as much as 2 weeks. Wall calendars commonly used in Israel are hybrids. Most are organized according to Gregorian rather than Jewish months, but begin in September, when the Jewish New Year usually falls, and provide the Jewish date in small characters. Other practices, outside of Rabbinic Judaism, evidence shows a diversity of practice. Keralite Calendar. Keralites use the lunar month and the solar year, but the Keralite calendar differs from the current Rabbinic calendar in a number of ways. The Keralite calendar is identical to the rabbinical calendar used before the Sanhedrin changed the rabbinic calendar from the lunar, observation-based calendar, to the current mathematically based calendar used in Rabbinic Judaism today. In the lunar Keralite calendar, the beginning of each month, the Rosh Chodesh, can be calculated, but is confirmed by the observation in Israel of the first sightings of the new moon. This may result in an occasional variation of a maximum of 1 day, depending on the inability to observe the new moon. The day is usually picked up in the next month. The addition of the leap month is determined by observing in Israel the ripening of barley at a specific stage, rather than using the calculated and fixed calendar of Rabbinic Judaism. Occasionally this results in Keralites being 1 month ahead of other Jews using the calculated rabbinic calendar. The lost month would be picked up in the next cycle when Keralites would observe a leap month while other Jews would not. Furthermore, the seasonal drift of the rabbinic calendar is avoided, resulting in the years affected by the drift starting 1 month earlier in the Keralite calendar. Also, the 4 rules of postponement of the rabbinic calendar are not applied, since they are not mentioned in the Tannaitic. This can affect the dates observed for all the Jewish holidays in a particular year by 1 day. In the Middle Ages many Keralite Jews outside Israel followed the calculated rabbinic calendar, because it was not possible to retrieve accurate Aviv barley data from the land of Israel. However, since the establishment of the State of Israel, and especially since the Six-Day War, the Keralite Jews that have made Aliyah can now again use the observational calendar. The Qumran Calendar. Many of the Dead Sea Scrolls have references to a unique calendar, used by the people there, who are often assumed to be Essenes. The year of this calendar used the ideal Mesopotamian calendar of 12 30-day months, to which were added 4 days at the equinoxes and solstices, making a total of 364 days. There was some ambiguity as to whether the cardinal days were at the beginning of the months or at the end, but the clearest calendar attestations give a year of 4 seasons, each having 3 months of 30, 30, and 31 days with the cardinal day the extra day at the end, for a total of 91 days, or exactly 13 weeks. Each season started on the 4th day of the week, every year. With only 364 days, it is clear that the calendar would after a few years be very noticeably different from the actual seasons, but there is nothing to indicate what was done about this problem. Various suggestions have been made by scholars. One is that nothing was done and the calendar was allowed to change with respect to the seasons. Another suggestion is that changes were made irregularly, only when the seasonal anomaly was too great to be ignored any longer. The writings often discuss the moon, but the calendar was not based on the movement of the moon any more than indications of the phases of the moon on a modern Western calendar indicate that that is a lunar calendar. The calendrical documents 4Q320 and 4Q321 from the Dead Sea Scrolls outlining the 364-day solar calendar, 6-year cycle of priestly courses, and 354-day lunar year cycles may be found here. In addition, an abbreviated Jubilee calendar from 4Q319 along with a priestly course serving on 1 Abib each year may be found here. Persian civil calendar. Calendrical evidence for the post-exilic Persian period is found in papyri from the Jewish colony at Elephantine, in Egypt. These documents show that the Jewish community of Elephantine used the Egyptian and Babylonian calendars. The Sardica Paschal table shows that the Jewish community of some eastern city, possibly Antioch, used a calendrical scheme that kept Nisan 14 within the limits of the Julian month of March. Some of the dates in the document are clearly corrupt, but they can be amended to make the 16 years in the table consistent with a regular intercalation scheme. Peter, the Bishop of Alexandria, mentions that the Jews of his city hold their Passover according to the course of the moon in the month of Phamnoth, or according to the intercalary month every 3rd year in the month of Pharmathi, suggesting a fairly consistent intercalation scheme that kept Nisan 14 approximately between the Phamnoth 10 and Pharmathi 10. Jewish funerary inscriptions from Zoar, south of the Dead Sea, dated from the 3rd to the 5th century, indicate that when years were intercalated, the intercalary month was at least sometimes a repeated month of Adar. But the inscriptions reveal no clear pattern of regular intercalations, nor do they indicate any consistent rule for determining the start of the lunar month. In 1178, Maimonides included all the rules for the calculated calendar and their scriptural basis, including the modern epochal year in his work, Mishneh Torah. Today, the rules detailed in Maimonides' code are those generally used by Jewish communities throughout the world. Astronomic calculations, synodic month the Molad interval, a new moon is the moment at which the sun and moon are aligned horizontally with respect to a north-south line. The period between two new moons is a synodic month. The actual length of a synodic month varies from about 29 days 6 hours and 30 minutes to about 29 days and 20 hours, a variation range of about 13 hours and 30 minutes. Accordingly, for convenience, a long-term average length called the mean synodic month is used. The mean synodic month is days, or 29 days, 12 hours, and 793 parts, and is the same value determined by the Babylonians in the system B in about 300 BCE and was adopted by the Greek astronomer Hipparchus in the 2nd century BCE and by the Alexandrian astronomer Ptolemy in Almagest 4 centuries later. Its remarkable accuracy is thought to have been achieved using records of lunar eclipses from the 8th to 5th centuries BCE. This value is as close to the correct value of 29.530589 days as it is possible for a value to come that is rounded off to whole parts. The discrepancy makes the molad interval about 0.6 seconds too long. Put another way, if the molad is taken as the time of mean conjunction at some reference meridian, then this reference meridian is drifting slowly eastward. If this drift of the reference meridian is traced back to the mid-4th century, the traditional date of the introduction of the fixed calendar, then it is found to correspond to a longitude midway between the Nile and the end of the Euphrates. The modern molad moments match the mean solar times of the lunar conjunction moments near the meridian of Kandahar, Afghanistan, more than 30 degrees east of Jerusalem. Furthermore, the discrepancy between the molad interval and the mean synodic month is accumulating at an accelerating rate, since the mean synodic month is progressively shortening due to gravitational tidal effects. Measured on a strictly uniform time scale, such as that provided by an atomic clock, the mean synodic month is becoming gradually longer, but since the tides slow Earth's rotation rate even more, the mean synodic month is becoming gradually shorter in terms of mean solar time. Seasonal drift. The mean year of the current mathematically based Hebrew calendar is more than 6 minutes and 25 seconds more than the Northern Hemisphere spring equinox year. The mean Hebrew year is 365 days 5 hours 55 minutes and 25 plus 25 over 57 seconds. A euro computed as the molad monthly interval of 29.530594 days. 235 months in a 19-year Metonic cycle, 19 years per cycle. The present era mean northward equinoctial year is 365 days 5 hours 49 minutes 1 second long, resulting in a seasonal drift of the Hebrew calendar in relation to the tropical year of about a day every 224 years. In relation to the Gregorian calendar, the mean Gregorian calendar year is 365 days 5 hours 49 minutes and 12 seconds, and the drift of the Hebrew calendar in relation to it is about a day every 231 years. Implications for Jewish ritual. Although the molad of Tishrei is the only molad moment that is not ritually announced, it is actually the only one that is relevant to the Hebrew calendar, for it determines the provisional date of Rosh Hashanah, subject to the Rosh Hashanah postponement rules. The other monthly molad moments are announced for mystical reasons. With the moladot on average almost 100 minutes late, this means that the molad of Tishrei lands 1 day later than it ought to in a equals 5 of 72 years or nearly 7% of years. Therefore, the seemingly small drift of the moladot is already significant enough to affect the date of Rosh Hashanah, which then cascades to many other dates in the calendar year and sometimes, due to the Rosh Hashanah postponement rules, also interacts with the dates of the prior or next year. the molad drift could be corrected by using a progressively shorter molad interval that corresponds to the actual mean lunar conjunction interval at the original molad reference meridian. Furthermore, the molad interval determines the calendar mean year, so using a progressively shorter molad interval would help correct the excessive length of the Hebrew calendar mean year, as well as helping it to hold on to the northward equinox for the maximum duration. When the 19-year intercalary cycle was finalized in the 4th century, the earliest Passover coincided with the northward equinox, which means that Passover fell near the first full moon after the northward equinox, or that the northward equinox landed within one lunation before 16 days after the molad of Nisan. This is still the case in about 80% of years, but in about 20% of years Passover is a month late by these criteria. Presently this occurs after the premature insertion of a leap month in years 8, 11, and 19 of each 19-year cycle, which causes the northward equinox to land on exceptionally early Hebrew dates in such years. This problem will get worse over time, and so beginning in AM 5817, year 3 of each 19-year cycle will also be a month late. Furthermore, the drift will accelerate in the future as perihelion approaches and then passes the northward equinox, and if the calendar is not amended then Passover will start to land on or after the summer solstice around AM 16652. The seriousness of the spring equinox drift is widely discounted on the grounds that Passover will remain in the spring season for many millennia, and the text of the Torah is generally not interpreted as having specified tight calendrical limits. On the other hand, the mean southward equinoctial year length is considerably shorter, so the Hebrew calendar has been drifting faster with respect to the autumn equinox, and at least part of the harvest festival of Sukkot is already more than a month after the equinox in years 1, 9, and 12 of each 19-year cycle. Beginning in AM 5818, this will also be the case in year 4. This progressively increases the probability that Sukkot will be cold and wet, making it uncomfortable or impractical to dwell in the traditional sukkah during Sukkot. The first winter seasonal prayer for rain is not recited until Shemini Atzeret, after the end of Sukkot, yet it is becoming increasingly likely that the rainy season in Israel will start before the end of Sukkot. No equinox or solstice will ever be more than a day or so away from its mean date according to the solar calendar, while 19 Jewish years average 6939d 16 hours 33 m 031 3s compared to the 6939d 14 hours 26 m 15s of 19 mean tropical years. This discrepancy has mounted up to 6 days, which is why the earliest Passover currently falls on March 26. Worked example, given the length of the year, the length of each month is fixed as described above. So the real problem in determining the calendar for a year is determining the number of days in the year. In the modern calendar this is determined in the following manner. The day of Rosh Hashanah and the length of the year are determined by the time and the day of the week of the Tishrei Molad, that is, the moment of the average conjunction. Given the Tishrei Molad of a certain year, the length of the year is determined as follows. First, one must determine whether each year is an ordinary or leap year by its position in the 19-year Metonic cycle. Years 3, 6, 8, 11, 14, 17 and 19 are leap years. Secondly, one must determine the number of days between the starting Tishrei Molad and the Tishrei Molad of the next year. For calendar descriptions in general the day begins at 6 p.m., but for the purpose of determining Rosh Hashanah, a molad occurring on or afternoon is treated as belonging to the next day. All months are calculated as 29d, 12 hours, 44 m, 31 3s long. Therefore, in an ordinary year TM2 occurs 12 Monlen days after TM1. This is usually 354 calendar days after TM1, but if TM1 is on or after 3:11 and 20 seconds am and before noon, it will be 355 days. Similarly, in a leap year, TM2 occurs 13 Monlen days after TM1. This is usually 384 days after TM1, but if TM1 is on or afternoon and before 2:27 162 or 3 p.m., TM2 will be only 383 days after TM1. In the same way, from TM2 one calculates TM3. Thus the four natural year lengths are 354, 355, 383, and 384 days. However, because of the holiday rules, Rosh Hashanah cannot fall on a Sunday, Wednesday, or Friday, so if TM2 is one of those days, Rosh Hashanah in year 2 is postponed by adding 1 day to year 1. To compensate, 1 day is subtracted from year 2. It is to allow these adjustments that the system allows 385-day years and 353-day years besides the 4 natural year lengths. But how can year 1 be lengthened if it is already a long ordinary year of 355 days, or year 2 be shortened if it is a short leap year of 383 days? That is why the 3rd and 4th DNI years are needed. If year 1 is already a long ordinary year of 355 days, there will be a problem if TM1 is on a Tuesday, as that means TM2 falls on a Sunday and will have to be postponed, creating a 356-day year. In this case, Rosh Hashanah in year 1 is postponed from Tuesday. As it cannot be postponed to Wednesday, it is postponed to Thursday, and year 1 ends up with 354 days. On the other hand, if year 2 is already a short year of 383 days, there will be a problem if TM2 is on a Wednesday, because Rosh Hashanah in year 2 will have to be postponed from Wednesday to Thursday, and this will cause year 2 to be only 382 days long. In this case, year 2 is extended by 1 day by postponing Rosh Hashanah in year 3 from Monday to Tuesday, and year 2 will have 383 days. Rectifying the Hebrew calendar. The attribution of the fixed arithmetic Hebrew calendar solely to Hillel II has, however, been questioned by a few authors, such as Sacha Stern, who claim that the calendar rules developed gradually over several centuries. Given the importance in Jewish ritual of establishing the accurate timing of monthly and annual times, some futurist writers and researchers have considered whether a corrected system of establishing the Hebrew date is required. The mean year of the current mathematically based Hebrew calendar is more than 6 minutes and 25 seconds in excess of the Northern Hemisphere spring equinox year, and has drifted an average of 7-8 days late relative to the equinox relationship that it originally had. It is not possible, however, for any individual Hebrew date to be a week or more late, because Hebrew months always begin within a day or two of the molad moment. What happens instead is that the traditional Hebrew calendar prematurely inserts a leap month 1 year before it should have been inserted, where prematurely means that the insertion causes the spring equinox to land more than 30 days before the latest acceptable moment, thus causing the calendar to run 1 month late until the time when the leap month should have been inserted prior to the following spring. This presently happens in 4 years out of every 19-year cycle, implying that the Hebrew calendar currently runs 1 month late more than 21% of the time. To a minor degree, the tardiness of the calendar is also due to not correcting for the progressively shorter mean astronomical lunation interval although presently this only accounts for a little over 6 seconds of the yearly equinox drift, it more importantly accounts for nearly 2 hours of molad drift relative to actual mean lunar conjunctions, which is enough to cause Rosh Hashanah to start on the wrong date in an appreciable number of years. Dr. Ive Bromberg has proposed a 353-year cycle of 4366 months, which would include 130 leap months, along with use of a progressively shorter molad interval, which would keep an amended fixed arithmetic Hebrew calendar from drifting for more than 7 millennia. It takes about 31 or 2 centuries for the spring equinox to drift an average of 1/19 of a molad interval earlier in the Hebrew calendar. That is a very important time unit, because it can be cancelled by simply truncating a 19-year cycle to 11 years, omitting 8 years including 3 leap years from the sequence. That is the essential feature of the 353-year leap cycle plus 11 plus equals 353 years. Religious questions abound about how such a system might be implemented and administered throughout the diverse aspects of the world Jewish community. See also: Assyrian calendar, Babylonian calendar, biblical and Talmudic units of measurement, Kol HaMoed, the intermediate days during Passover and Sukkot. Chronology of the Bible, counting of the Omer, Islamic calendar, Jewish and Israeli holidays 2000 2050, Lag BaOmer, 33rd day of counting the Omer. References. Bibliography, Al-Biruni. The Chronology of Ancient Nations, Chapter 7. Tr. C. Edward Sackow. London, 1879. Ari Bielinki. A unique feature of the Jewish calendar Diot. Culture and Cosmos 63 Euro 22. Jonathan Bendov. Head of All Years, Astronomy and Calendars at Qumran in Their Ancient Context. Leiden, Brill, 2008. Bonnie Blackburn and Leo Frank Holford Strivens. The Oxford Companion to the Year, An Exploration of Calendar Customs and Time Reckoning. Oxford University Press. USA, 2000. Sherrod Beaumont Burnaby. Elements of the Jewish and Mohammedan Calendars. George Bell and Sons, London, 1901. Nathan Bushwick. Understanding the Jewish Calendar. Motzem, New York Jerusalem, 1989. ISBN 0-940118-17-3, William Moses Feldman. Rabbinical Mathematics and Astronomy, 3rd edition, Sefer Hermann Press, New York, 1978. Duard Mahler, Handbuch der Jahr 1/4 edition Chronology. Buchhandlung Gustav Fock, Leipzig, 1916. Otto Neugebauer. Ethiopic Astronomy and Computers. Historische Akademie der Wissenschaften, Philosophische Historische Klasse, Sitzungsbericht 347. Vienna, 1979. The Code of Maimonides, Book 3, Treatise 8, Sanctification of the New Moon. Translated by Solomon Gandz. Yale Judaica Series Volume 11, Yale University Press, New Haven, Connecticut, 1956. Samuel Poznansky. Calendar. Encyclopedia of Religion and Ethics T. and T. Clark, Edinburgh, 1910, Vol. A3, ppA 117 Euro 124. Edward M. Reingold and Nachum Dershowitz. Calendrical Calculations, the Millennium Edition. Cambridge University Press. 2 edition. ISBN 0-521-77752-6, 723 Euro 730. Louis A. Resnikoff. Jewish Calendar Calculations, Scripta Mathematica 9 191 Euro 195, 274 Euro 277. Duard Schwartz, Christliche Jahr 1/4 des Ostertafel, Berlin, 1905. Arthur Spear. The Comprehensive Hebrew Calendar, 20th to the 22nd Century 5660 Euro 5861,900 Euro 2100. Feldheim Publishers, Jerusalem, New York, 1986. Sacker Stern, Calendar and Community, A History of the Jewish Calendar 2nd Century BCE to 10th Century CE. Oxford University Press, 2001. ISBN 9780198270348. Ernest Wisenberg. Appendix, Addenda and Corrigenda to Treatise 8. The Code of Maimonides, Book 3, The Book of Seasons. Yale Judaica Series Volume 14, Yale University Press, New Haven, Connecticut, 1961 ppA 557 Euro 602. Francis Henry Woods. Calendar, Encyclopedia of Religion and Ethics T. and T. Clark, Edinburgh, 1910, Vol. A3, ppA 108 Euro 109. External links, Perpetual Hebrew/Civil Calendar, Jewish Calendar with Halachic Times Date Converter and Daf Yomi Yeshiva Co., The Jewish Controversy About Calendar Postponements, Jewish Calendar with Zmanim Euro Halachic Times and Date Converter Shabbat.org, Jewish Calendar Scientific Explanation at the NASA website, Keralite Holidays Keralite website, Hebrew Calendar Dates and Holidays for both the traditional and the rectified calendars, Hebrew Euro Gregorian Calendar with options, Bet HaBraja Hebrew Calendar A Hebrew Calendar with Halachic Times, at yeshiva.org.il, Date Converters, Jewish Holidays Online A Euro List of all Jewish holidays for the current year. Molad A Euro Jewish Calendar with Zmanim and holidays for mobiles. Jewish Calendar for many platforms, Kaluach A Euro Hebrew Civil Calendars, HTML Hebrew Date Converter, sample VB.NET and JavaScript code to convert the Hebrew date to the Gregorian date at the Wayback Machine, Jewish/Civil Date Converter, software program that converts Hebrew dates to the civil calendar and vice versa, Gregorian Mayan Julian Islamic Persian Hebrew Calendar Converter, Calendar Calculator, Firefox add-ons. Hebrew Calendar, Lisp Calendar Calculator which accompanies Dershowitz and Reingold's Calendrical Calculations 3rd ed. Click Ancillary Materials tab. Hebrew Gregorian Converter, including a full Hebrew calendar. Hebrew Gregorian Calendar Converter, including a full Jewish calendar. JCAL for Windows, full Jewish Gregorian calendar for Windows with explanation.